So we're going to look at equilibrium, and you can probably pause the presentation here and jot down 3 ideas that equilibrium mean to you at the moment. And at the end of the exercise, you can add what more you understand about chemical equilibrium. And we're going to look at formulas here of copper-2 sulfate, hydrated copper-2 sulfate, and aqueous copper-2 sulfate. And to think at the end, to find 6 reversible reactions that are significant to your everyday life. And we're going to start with hydrated copper sulfate, and we're going to dissolve that in water to make a 0.2 molar solution. And we've got a formula here, and it shows 6 water molecules. Lone pairs of electrons on the delta negative oxygen atoms are attracted to the copper 2 plus ions, and there are 6 of them, and that's going to be different from the 5 water molecules that are associated in the solid hydrated crystal. And the water here, because of the lone pairs of electrons that are attracted to the positive copper ion, it's called a ligand. And then when we add concentrated hydrochloric acid, pour it slowly down the inside of the tilted flask, it changes colour. And why does it change colour? Colour change is a characteristic of a chemical reaction, and here we're actually making a copper chloride complex, which is green, as opposed to the sulfate, which is blue. Then when we add concentrated ammonia, we get copious white clouds above it, and they are due to ammonium chloride, which in the equation here is shown as a solid. So it's almost as if it's sort of a dust particle. But if you leave it for a while, it settles out, and that ammonium chloride actually dissolves in the solution, and it stays green. Now, if we add concentrated ammonia to the solution, we actually get a color change to light blue, and that is due to really the formation of copper-2 hydroxide. If we continue adding concentrated ammonia, it goes to a deep blue, because you make a complex ion where you have 4 ammonia molecules with each of the copper ions, the cuprammonium complex. So these are ammonia molecules with no charge, and the copper is still a copper-2 ion. And so what is the chemistry looking at here? We're making a complex ion. There's an entropy change when you're dissolving solids in liquids, and indeed making the solid ammonium chloride. And if we add some more concentrated HCl, it goes back to being the green color, and you get the ammonium chloride fog above it. The reaction is reversible. So what's actually happening here with the formulas, it's going both ways. And in fact, if you look at the bottom reaction here in red, you can see a reversible arrow. So for the forward reaction, the chemicals on the left are the reactants. For the reverse reaction, the chemicals on the right are the reactants. And there's a stylized reaction, A plus B gives and doesn't give, with the reversible arrows, C plus D. And what happens if we want to disturb the equilibrium? You add more of one of the chemicals. So what is actually going to happen? You're going to shift the reaction. You shift it away from what you add. There's another lab which will show that as well. Our vocabulary is using the word dynamic equilibrium. The reaction doesn't just reach a balance and stay there. the forward reaction continues and the reverse reaction, but you get a balance and an equaling amount of right-hand side chemicals that stay the same in the mixture, and you get an amount of left-hand side chemicals which will stay the same, but it's dynamic. And then if you look at the graph here for the reaction that's shown, the concentration of one of the reactants will decrease, the concentration of one of the others products will increase until you get a balance between the two, and the parallel lines are going to give you the equilibrium. Just doesn't occur to chemical reactions, also occurs to a physical system, and if you gently heat some iodine in a sealed aluminum flask and heat it very gently, you've got a sealed system so don't heat it strongly, you'll see the iodine solid form the vapor. That's a bit of sublimation. And if you look at the diagram of another halogen, it's bromine liquid, which are the dots shown at the bottom of the containers, in equilibrium with gaseous molecules of bromine. And so if you pour some bromine into a container and put a lid on it, got all liquid, and you will see some vapor form. So the very dark brown vapor forms an orangey brown gas above it, and this will happen and keep happening until the numbers of vapor molecules that are condensing into the liquid at the bottom and the number of liquid molecules that are vaporizing are equal. You will have an equilibrium with the vapor above the liquid and the liquid itself.